Hey, how's it going?
Hey Ben, morning.
Morning.
It's cold over there.
Oh, it's very cold. It's very cold. I got the heat on in the garage, but it's not doing quite as much as I'd hope it'd be doing. So keep
Oh man,
layers on. It's one time of
here
year
in Florida,
to be fat.
yeah. What is it?
It's the one time of year where it's actually good to be fat, you know.
I guess so. Yeah, absolutely. It's actually coldish here. I think this morning it was 58, 57. Is that
Nice.
cold for you, or is that just
Yeah, sure. It sounds about like 17 degrees Fahrenheit. So yeah, it sounds cool. Hey,
Celsius? Yeah.
by the way, I'm going to send you a link to our agenda that we
Okay.
have just for people to like start adding items to. I know some people
Oh,
want to see
okay.
stuff on agenda in terms of whether they should join or not. So
Yep.
feel free to add. I'm just doing like, basic stuff. So if you have anything that you want to share on the agenda, we'll wait a few minutes for James to join. And I don't know if Peter's going to join or not. Hopefully he
Sure.
does.
Okay.
But yeah.
Can you guys...
Yeah, I can hear you.
Oh, I like your stocking cap.
Oh, thank you. I also have my hoodie on. So it's the bright side is when you can clothe yourself and keep warm, but also be on brand for your call. So it's very cold.
Are you in your shed right now?
No, I'm in the garage. Might as well be the shed.
Yeah.
I am recording all these calls just as a heads up to everybody.
Okay.
And I do want to have like a
son of a
oh no. So if we do want to talk about something that we don't want recorded, just let me know, and I think I can pause the recording. I was also planning, just because of the access for the recordings, technically anybody who's invited to the call has access, which technically I believe all of you guys have that invite, but there seemed to be some weird permissions for Lewis last time with getting access to it, even though it should have just been easy and no issue. So I was thinking of just automatically uploading these calls to like our YouTube channel, unless if people have a reason not to, just because that's like the easiest, lowest effort access. And if we want to share it with somebody who's not on the call, then it's also not painful, right?
and I can watch it on my TV.
There you go. Watch on your TV. So I do want to have a vote. Maybe I don't know if Peter was going to join as well, but I want sort of the core people that typically join on the call to say whether or not they felt comfortable with that. And maybe we have a vote to decide whether we're good with that or not. I get it if you don't necessarily like that, but I don't think we're really ever sharing anything that we cared not to share in a less controlled fashion anyhow. And I guess if we ever do decide that, we can always ask to pause the recording in the meeting.
Yeah. Or you could have a planned, let's say, confidential section, or at the beginning or the end.
Sure. Yeah, there's a variety of things that we can do to accommodate it. Or like, you just pause the meeting whenever somebody says, hey, I want to talk about this, but I don't think it should be recorded. Pause the recording, right? So I guess we got 4 people right now. So I don't know, probably enough of a quorum if we wanted to take a vote anyhow. Not that we have strict rules around quorum. So I guess I'll move that to being done first. So I guess, do we want to take a vote on that?
Okay. What's the motion?
Second.
Okay. So
what is the official motion?
to upload meetings that we have recorded to YouTube afterwards. And then I'll put in things right here with exceptions for requests to have them to have private not recorded. Recorded. I.e. pausing. All right. So yeah, I think that's fine. We have a agenda technically that's attached as well to all the calendar things. So anybody who wants to add to the agenda, we have an agenda. I believe everybody should have in this call permissions to edit it or see it. So that way we can sort of keep as close of a structure as we can. And make this hopefully very productive for everybody instead of just, a free-for-all necessarily. Not that that's always a bad thing, but all right. On that note, I guess who wants to, second the motion for the recording?
I'll second it.
Okay.
Let's see.
All right, there we go. And then let's just, I guess, take a vote. Just how about we do a consensus? So anybody opposed? Nope. All right, cool. So then we go consensus. All right. All right. So the first thing that I was wanting to do is just go over our project board. The next thing was I want to have Lewis go over his items that he added to the agenda. And then James, I think if you have the ability to share a little bit of what you've worked on, that would also be great.
Yeah, sounds good.
I'm going to pull up the project board and screen share that. Give me 1 second.
I should note, Benjamin, I need to leave on the half hour. So if there's anything specific for me.
We can move the let's move the project board to the end then.
Yeah. I'll share real quick something that's interesting. Let's see. That is the wrong screen. Okay. Can you guys see my screen?
Yep.
We can see that.
So this is really cool. So Purdue is part of this push to get an FAA test site. And we've been talking, I'm part of the working group that's pushing this forward, and we're kind of the academic side. But basically, it's pretty cool. This article mentions Perk. I'm trying to get everybody on board and together. Basically, Indiana is trying to become a drone manufacturing corridor. And, they talk about, Perk being an asset, the largest indoor motion capture facility in the world, right? So I think it's pretty cool. We're getting some nice publicity. We're working with the senator from Indiana. So I think, I forget what this was. It's like an $80 million thing if we get it. So it could be really cool. Of course, that'll be split across a bunch of different vendors, but it would make this, it would put a lot of backing behind CogniPilot.
Very nice.
To that note, also just ad hoc, we did have some discussions with Greensight, and we're looking at spooling up a consortium. And that consortium basically being NXP, Purdue, and Greensight, at least initially, for doing development work, basically between hardware, software, and test facilities for really accelerating sort of the next generation of drone autonomy and architectures. So hopefully we can get a call on that before everybody goes on winter break, but I think that's also a pretty exciting opportunity there that we should follow up on.
Yeah, and I think it's nice to have a little bit of a formalized architecture there that lets other people join. It lets you sort of act as an entity. It helps us in terms of, us spending time, not just with random ad hoc people. It's now part of a consortium, and it'll work out well.
And it also allows people easily a way to understand how to join and what's expected of them when they join, right? Whereas like technically CogniPilot is always going to be open, no commitments needed. Use it, don't use it. But hey, if you want some more focused advantages, then join a consortium and, you know, say, hey, I want to, you know, share this in exchange for this kind of type thing, which I think makes a lot of sense for everybody as well. On that note, by the way, Peter, if you have anything you want to talk about, feel free to add to the agenda, as long as we can get to it. On that note, I might actually open it up then to Lewis to go over his stuff, so you can go over stuff while you're still on the call, Iain.
Yep.
Yeah, I will mention a couple things real quick. So, as I mentioned last week, all the ZROS drivers have a PR up, including IMU with multiple instances, the Ranger, the optical flow, and the magnetometer. The ZROS driver repo has already merged the IMU and the magnetometer. That was merged, I think, by the end of last week. Benjamin, is that correct? Yeah. I'm dealing with an issue with the AFBR S50 driver. Essentially, everything works well for a couple hours, but as soon as the Ranger needs to recover, the scheme between, you know, stopping the ongoing timer of the driver and restarting it, it's tripping up. So essentially, I've been looking at this for a couple days, and I'm pretty sure I got a solution. I just need to implement it, because it's not a one-liner fix. If it was, already been implemented. Other than that, already received by the end last week the messages that we want to see on the ROS, on the PB and ROS2 side from Benjamin. Includes all the information associated with the AFBR, the Argus data, and also the optical flow. So as soon as I'm done with the bug, I'll proceed with that. I am also, you know, looking for feedback. I know we tried to do like an on-site testing last week with the RDD2 firmware, Cerebri. I'm wondering if we're planning to do that sometime in the future. It doesn't have to be on the weekly meeting. We can schedule some of the time, but I'd be curious to see, you know, the full-on application, you know, the drone flying with the drivers that I've developed. I'd like to see that happening. I think everyone wants to as well. Just to clarify, the RDD2 app with the current mainline has 2 IMUs running at 800 hertz, and basically just one of those IMUs is what's feeding the rest of the application. It hasn't actually been, you know, processed or done anything with respect to that. But yeah, I'll pause for a second. Do you guys have any questions?
Where does the GNSS side of things fit in here anywhere?
Yes, the ZROS driver for the GNSS Zephyr GNSS, it's already integrated, and that's essentially GNSS is working with that already. The part that's missing is the RTK integration side. Okay. That's a joint effort between Ben and I. I'm willing to do it like as soon as we set some time aside to just figure out how to get the data from the Linux side or from the compute module to the microcontroller side, and that's basically, this is a joint, in that sense, that's a joint effort. I'm willing to do it as soon as Ben has some time.
Is that the anticipated architecture from the Linux host, or is there also an opportunity for like a radio feed of corrections or something from a ground station?
Yeah, that's a good question. It's really open. It's really open, and what I had in my mind was that Linux,
one doesn't preclude the other, right? I mean,
exactly. I was just had in my mind a specific hardware that has like the NavQ Plus or the IMX95 that already has, you know, network access, like internet access. So essentially, you can get the data anywhere, and that's the easiest way to integrate it at first. But for sure, you can integrate it. There's many ways to integrate that, and yeah. If you'd like to discuss in more detail, perhaps we just open a thread in the Discord channel and see, hey, what's the first way we want to integrate this as? And I think it should include all the others. Yeah.
How close are we on the shield, by the way, Iain? Not that we have to use, well, we either need to use the shield or we need the IO adapter board for us to actually do that Ethernet, T1 Ethernet integration path through the MCXN one way or another. But
so we are, how close are we? trying to think of the way to word it. It's done. However, there was questions raised about the 50 ohm. There's like a, I don't know, 11 millimeters or 8 millimeters of 50 ohm trace that goes from the antenna to the processor. It's the correct strip line. However, the passives that are on it are larger, and it was raised that that's probably going to create discontinuities or stubs as a result of like a cap sitting on the trace, because the block of the trace is bigger than the actual trace. And it was asked to me, maybe we can move those down to much smaller parts. I think they're 0402s, and they might have to go to 0201s. That would help. And I had identified some people that could review this that had the RF background, and I just have been completely pulled away with everything else going on. So it's kind of minor, but it's also major that it needs some focus and attention to get it done. But everything else is done. Everything else is complete, ready to go. And so we're just stuck on this one detail. And, I would say personally, it's probably fine the way it is, even, or there'd be some kind of losses. So GPS is slightly less performant than optimal, but it would work, I'm sure. But why, we have a little bit of time. Let's try to do it right.
Okay. Yeah. Thanks for that.
I can't make any promises, but perhaps I'm having some time off here between now and the end of the year. So
take the time off. You don't need to work on
it. Nothing going on.
Yeah.
Just time with family or work on GNSS. I don't know. It's the holidays. You'll give the family at least 2 solid days of trying it before you open up my cat. Okay, well, I appreciate that update. That's good to know. I feel like along those same notes, while people are on here, and also you, Iain, I'll go back to my one point on the agenda that I wanted to bring up, which is PTP for the MCXN 947. Because I think that was one of the things we were looking at. Was, you can get GPS time, GNSS time, and you can feed it into a system. And we're like, oh, that's great. PTP. And I think technically, from what we've looked up, the MCU SDK has not implemented PTP for the 947, but the 947, from a silicon perspective, doesn't inherently exclude the capabilities for doing PTP. Is that sort of what we saw when we dug into that, Iain, if I remember correctly?
Oh, is that I don't recall. I think. Oh, I see now. No, the 947 MCXN has IEEE 1788. It has that capability. It was the MCX. The MCX parts. Oh, sorry. What am I thinking? Wait on. MCXN 947. Is that the part you're talking about? Yeah. Okay. Yeah, there's some weird comment about. Yeah, there's some weird detail that it technically has something under the hood, but it's not been implemented in any way. So this, so I don't know what we would do there. I mean, it's kind of we're off in uncharted territory until somebody at a low level wanted to investigate that further. So
you don't, Peter. Do you have any knowledge on PTP capabilities for the 947 or not? Or have you investigated that at all?
No, the only thing I know that they're enabling it on the NetC part on the 9.5, so maybe that's a basis. But effectively,
so
it's
you're talking about a different part. That's an IMX 9.5. This is
MCX. But the trick is that the PHY does the timestamping, because that's where you don't get the. That's how it becomes precise. So there's some smartness involved in the PHY. And then there's some way to get that over to the running timer of the hardware, which is the Mac. The Mac supports PTP, and that rolls it, and then there's some compensation because even the time to transfer between the PHY and the Mac, you compensate back to that, but then you make sure that the PHYs do the stamping. So there is a high-level implementation inside of Zephyr for PTP. We have all the hardware that supports it. I guess on the PHY level, we can play around with other PHYs. So I guess making it work it's doable. Making it like precise, that's the pain point with PTP.
Yeah, and I think precise maybe has an asterisk around it as well, right? Like, is it better than NPT or NTP? Network time
I think
protocol,
yeah, I think the goal
okay.
would be to outperform NTP and like
Exactly.
aim for like a microsecond precision. But then like the crazy one goes to like pico or nano, whatever. I don't know exactly, but like there are these theoretical maximum. But if you know that the error initially is a microsecond, for the sake of logging, that's cool. But there are people like doing with external sensors and all that stuff where they need to have this crazy synchronization. But then it even becomes more complicated because then you might generate a shitload of traffic doing the synchronization, because the thing is about you have two free rolling timers, and the trick is to send packets to make sure they are not skewing too much. So even that's a trade-off.
Okay, well, I think that's something that we should definitely have on our list to look at, because I know that's part of sort of our goals is that, cool, we have this distributed Ethernet or whatever connected basis of all these nodes and capabilities, but if they don't share a time basis, then, or at least a reasonable time basis, then we're sort of in trouble. Right? Anybody using it in robotics is in trouble, regardless of what software they're using. So yeah, I'll be interested to poke and prod around that a little bit more to see what we can find out. But at least I think initial cursory look was like, should be able to do it. Asterisk, not been done yet from MCU SDK level, which doesn't mean it can't be done, just is odd that got left there. So hoping there's nothing further down. Hoping there's no hidden reason why it was not done. Let me put it that way in MCU SDK, right? So
I think it's lack of time, the fact that the other parts also don't have it. But the weird thing is actually, I think the ecos on the RT is kind of similar, at least that mechanism. So maybe we're lucky we can reuse stuff.
Yep. Okay. Yeah, because then we can serve time from GNSS, feed it to the whole system. That's the master node for PTP, more or less. And then yeah, that's a beautiful thing if we could have that working. That'd be amazing.
Well, ideally, actually, want to maybe turn the switch into master.
The switch into master?
Mm-hmm.
Can a master technically? But so the master is what says I have the time. Everybody else follows my time. So then, how does the master get the proper global time, or does the switch have a GNSS module on it? Right? How does that work?
Well, now you're gonna go through hubs. That's the thing. So that's already a trade-off you take. But then the question: do you want to have a precise synchronization, or do you have a precise definition of what the global time is? But you can also say, fuck that. Let's try to do that in 100 milliseconds accuracy, and then you make sure. Like, do you care about what the real time is, or do you care about synchronization between there? Like, do you really care? Yeah, right. So it's not that you want to have atomic clock precision of the exact time, because I don't know, you heard a loud bang at that position and you want to triangulate that with 100 drones, and you need to use your RJK GPS. I guess that could be a use case, but for now, just make sure that all the sensors have the same notion, and then you can still use the GPS for that. But even like if you have bad reception already, that timing is not that great, right? So
sure. Okay, cool. Well, I think that covered that item well. And then I guess the next one, I guess Iain, you probably only have a few minutes left, so I wasn't sure if there's anything you wanted to bring up right before you have to go or not? Or share?
I don't know. I can't think. I've sent out the Tropic with motor control all wired up.
Awesome.
You should, both James and you should be getting some.
I think it's coming today. At least I think I got a notice from FedEx that I have a package being delivered today.
Oh, okay.
So I think, I think we both should be getting those today, James.
Yeah, I think it only shipped yesterday, so it should be.
I want to show off Rumoca before we leave. This is for the model predictive control stuff. We basically now have the ability to generate Casati and all that online. Anybody in the world can now go to CogniPilot or Rumoca.cognipilot.com, and they have a WebAssembly based GUI, which means it's serverless. Yeah.
Do you want to show like your entire, if it's okay to share your entire screen so it actually even shows like where you're at? There you go. Okay. So yeah, you guys can go to Rumoca.cognipilot.org right now.
So this is cool. Like anybody in the world, bam. And this is WebAssembly, which means it's using your computer as the backend, but it has the compiler basically streaming to you, and nobody has to serve it. Your computer serves it. So we have like unlimited bandwidth. Anybody can have their own IDE. Like you guys can all be running this at the same time, and we're not going to upset Ben's server. Originally, I had this running on GitHub Pages. It also doesn't care if it's on GitHub Pages. This is the Modelica model, the quadrator over here. So this is what we want to consolidate all of our control and dynamics models in CogniPilot 2 so that we can quickly pass these around. And these are somewhat human readable versus our Casati code, which is gross. And once you have this, then you have a template. Like this template in the middle is our Casati renderer. And if I select over here that I want to see the pretty print, this is the pretty print of the internal representation of the equations after they've been flattened by the compiler. You can see we have, all these gross equations that you don't have to figure out because it solves it from the Modelica model. Over here, I can get the JSON. The JSON has all of the source code that this actually was compiled from. So it's exactly like the line number and file. In this case, you're in a WebAssembly editor, so it says the WASM file, but you get the idea. And then if we go to template, this is the Casati rendered, which basically plugs in directly to model predictive control and all the stuff we want to do with that. And very clean. And if you want to change the template, it's not magic. Like if I want to, I just added this parenthesized expression. So if I want parentheses to have a double parentheses, then I just come in here, and anybody that knows Jinja from like web development can do that. And then everywhere that actually has parentheses, it'll have two parentheses. So, and it's that fast, and it's running in real time. And the compiler, as I type things, it figures things out. And there's a very nice language server protocol running in here. So you get like autocomplete, and it actually does equation balancing. So if I do like real Z, it'll highlight this and say, your model's unbalanced. And then it'll come down here, undeclared Z variable not used. Basically, this is all the way real-time pipeline showing you what's happening. So now if I can say Z is equal to 1, now my model's balanced again, right? Completely insane that we have this capability now, and it's way better than any Modelica compiler that's existed to date. So Modelica is actually useful. We have a VS Code extension. So I tried to show some of you guys this last time, but if you want to go in and install the Rumoca VS Code extension, you click this, and I'm pushing updates like crazy, so you'll probably get an update every day. But we have 9 installs currently, which are probably most of my grad students that I'm making use this. But if you guys do that, it'll help us get some visibility, and I think that'll be really good. So if you like VS Code, it's there. If you want a full WebAssembly IDE in your browser, it's there. And this integrates with the Modelica standard library, so I can fetch. Now it's downloading Modelica standard library, so I have like all their definitions of PID controllers and things. And then watch this ridiculous autocomplete from my language server. The language server is completely written in Rust, but compiled to WebAssembly. So it's the output will say, okay, now your libraries are now cached for the Modelica standard library, and I can do modelica.blocks.continuous.PID. Bam, I have a PID controller, right? And then I can say PID1. And then I'll say, okay, that's great, but no, this guy's unbalanced, so I'll have to like define an equation, PID.y. And that's basically the power of this is that we don't have to reinvent the wheel because all these Modelica standard libraries exist. Yeah, so let me see. So basically that's what I'm working towards. And we're very close. So the compiler is not perfect, but I think we're very close, and we've got a group of people that are interested in pushing this forward. So yeah.
Very nice.
The other cool part is you can technically also run it from your cell phone too. So if you ever get
it does not.
I can have something to do when I'm at the airport.
There you go.
I think your cell phone is faster than your laptop with all the software running in the background.
Arguably, probably is.
I got to run to my.
All right, thanks, Iain.
Thanks, everybody.
And then let's take a minute to go through the project board here, and then we can wrap up the call. Just as heads up, Peter, we did have a vote earlier with consensus. We have agenda notes, so if anybody ever wants to bring up something, just add it to our agenda. It's attached to the meeting. It's agenda-developer call, and I think we're going to just have already the meetings are auto record. So if somebody wants to talk about something that they feel like they don't want to have auto recorded and just automatically shared, they can say, hey, can we pause the recording? I want to talk about something that I don't want recorded. We can easily pause the recording. And then all recordings, just for ease of access for people and ability to easily review. There's a nice linker for Google Workspaces where I can just automatically upload the calls after they're done to our YouTube page. Just so that way, not that we care about YouTube views or anything else like that. It's just more like it's the easiest way to be able to share it. And then also that way we can delete out the old recordings eventually after a couple weeks. So that way we're not losing a massive amount of like our drive space, because then YouTube is the one that has that as its storage instead of us having it as storage. So that also keeps us from burning through our drive storage in the Google Workspace fast. So yeah, if just want to give that as a heads up to everybody that by default these are just auto record. But once again, if you want to talk about something you don't feel comfortable about what you're talking about being publicly shared, just always let us know. It's not a big deal. We can pause it. Nobody's going to care. So all right, let me pull open our workspace here real quick. GitHub projects, and we'll quickly go through here and then we'll wrap it up. By the way, how did the competition go, James, while I load this up?
Really well. So you guys can see the leaderboard, and the people that actually were first on the leaderboard the day of actually won it. Let's see if I can. All right. And our trophy has pilot, CogniPilot logo on it. So and it's going to be in the display case at Armstrong. So
in the aviation hall. Well, that's actually pretty cool.
Yeah.
Nice. All right. So let me screen share this and we'll be good to go. Share screen. Entire screen. Here we go.
I'm going to beat you. Oh, wait.
Oh, all right.
Can I share my screen a second and then I'll give it back? Okay.
Go for it.
All right. Share screen. Screen one. Okay. So this was the competition. I don't know if you guys all got a chance to see the webpage. But then our leaderboard the day of was pretty crazy. So this is a drone following the two drones flying around in circles. And this is the leaderboard for the day right before. So the Network Control System Lab, which is another lab in AeroAstro, had a bunch of grad students show up, and they were doing this path integral control algorithm using all the CogniPilot software for the fixed wing. And they had a big GPU running, but they actually got beat by, in real life, they got beat by a team. It was like two freshmen. One of them was from like the Indianapolis campus, and one was from the Purdue campus, the West Lafayette campus. Yeah, it was really cool. I have more cool videos of the actual races, but I think the best lap time was around 12 seconds. So yeah, it was fun.
Do you just want to upload those videos, James, anyhow, to just like YouTube for people? Just tag it with
we'll have. I'll ask people to consolidate everything. We'll get the marketing and all that. Yeah.
Cool.
Yeah. All right. I will stop sharing. to figure it out. There we go.
All right, here we go. Is this good enough resolution for people to see? Somewhat. Does it need to be expanded a little more?
Maybe a bit more. Yeah.
Is that good? Hopefully. Or does it need more?
I don't know about you guys. It's a little bit blurry for me still, but
A little bit blurry. Do I have controls on share quality? Anybody else able to see it reasonably well, or is it blurry for them as well?
It's not sharp.
not sharing right now.
All right, let me.
It's like not bad. It's just.
Is it going up any now that I've stopped my video share?
We don't see anything right now.
I see the old thing.
Oh, you did?
Is that?
Let me stop presenting and I'll reshare it and see if it works happier now. Or I will just do a. All right. What about now? Is it looking okay?
It's good enough.
All right. Good enough. That's what we like here. All right. So, you know what? Let's just close out of all these extra applications that I'm sure are just absolutely fantastically great for absolutely everything that we have going on with that are eating everything. There we go. All right. Probably freed up a massive amount of stuff. So, let's just go to in review first. All right. So we have add IMU streaming node over RTIO. This one right here still needs flight testing by James. James, you said that you're basically busy until you finish writing your exam on Wednesday. Is that correct?
Yeah. Wednesday night is when I get free again. Yeah.
Okay. So Wednesday night, do you want to shoot me some calendar invite for Wednesday evening or something, and we can?
I'm probably gonna. So I get out of lecture at like 6, and then I'm gonna want to eat. So we'll say Thursday morning is when we can practically do something again. Yeah.
Okay. Sure.
Yeah.
If you want to shoot me a calendar invite or something.
Yeah.
For Thursday morning, that'd be great.
Yeah.
So right here we have add distance measurement node working over RTIO streaming mode. So this is what you were working on, Lewis.
Yeah, maybe move that back in progress because I found a bug and I'm just fixing it. So
okay,
back so we know it's not sitting on you guys to review.
Yep. Add optical flow node working over RTIO streaming mode. I believe this one still needs the full message. So let's put that back to in progress. Add magnetometer streaming node that works over RTIO. I believe that we approved and merged this, correct?
You click on this Manalo link real quick. Is that merged? Okay, yeah, that's done then. Let's move it out to them.
Okay. Yep, let's move that. I guess I could just say close issue anyhow, right? Because yeah, well, that works. So and let's see here. Add multi-IME stream node that works over RTIO. So merged into Spinali, but not done yet for Cerebri. So we will leave this open once again until testing. And please send calendar invite for testing to, yeah, well, you know, the calendar, yeah, spelling, you know, whatever, public schools, even though I didn't go to one, but whatever. All right, please send calendar invite for testing to there we go. On Thursday morning. All right, so there we go. Comment that, and we'll get that tested. And I know you mentioned that you wanted to sort of see it if possible, Lewis. So hopefully you can make some time happen on Thursday morning. Let's go over to in progress. So debug acro mode flight, RDD2 estimator correction, magcell GPS. So we're on the GPS aspect of that. I believe Yahor is on here, and Yahor was on here. I don't know if he's still on here or not. Or if he dropped.
I don't see him.
Yeah, he dropped already. Oh, well. I think he had done some stuff with GNSS related or GPS estimate. Update actually output 200 hertz. Okay. D-shot. So once again, these are all getting tested. So I believe this can go over to interview. This can go over to interview. And this I'm just gonna say this is done. We chose secure. So I'm gonna. Does anybody disagree on this one? But I'd say let's just mark it done because Iain got those in.
Yeah.
So close. Done. And
Is there a PR for that update to 200 hertz? Updating the actuator to 200 hertz?
nope, I don't think so. So in review, because this has already been merged in, where we updated it to 200 hertz, I believe. Right, Peter? Didn't you update the default to 200?
No, there was a sampling method, and then we said, why can't we just produce the higher rate from the control side, right?
Okay, so now it's based off of the control speed of the speed of the controller is the output
Instead
rate.
of doing the sampling, because otherwise you have to like wait, and then you have to like spit in between one, or you did the sleep method, but then you're unsynchronized. So effectively, if the control logic just produces 200 set points each second at least, then you don't have the latency problems, you don't have the sync problems, and ESCs are not kind of disarm themselves anymore because 100 is just like barely on the edge.
Oh crap! I just realized this. I think our controller now also runs off of the speed of the streaming IMU, and the streaming IMUs are now at 800 hertz, which means that our control output, I think, what did you see that coming output wise as, Lewis? Wasn't that like around 800 for the control output? So
You mean the odometry estimator? Or the control output? I don't think I monitor. If you like looking for the actuators, is that what you're asking?
yeah. So I think we'll have.
That's on the OpenPR anyways. So I guess that is this pending on that resolution to see if any change here is required, or it'll just work after that change?
We did revert the upsampling method, and then we discussed that if we have like better samples from IMU and like how the pipeline works, but effectively the actuator outputs hertz has to be 200 or higher. If it's below 100 or 100, then you just risk to have an ESC to pretty much press self-destruct.
I recall that issue. Then perhaps we just link it to the OpenPR that has the IMU streaming at 800 hertz. I do know for a fact the estimator updates at that very same rate. So,
yeah, but I think it's a pipeline. I think like changed that once before, like before it was even lower. So I guess it's the best to check what's going on there. I'm not sure how like tightly coupled that is.
Okay, understood.
I'll comment on it right here. We can link it to whatever we want to link it, but let's first do some testing tomorrow or Thursday, day after tomorrow.
The first basic thing is to like do ZROS topic hertz on actuator outputs on that branch, right? Just see what it actually is.
Yeah. Yeah. So my suggestion would be to move this back in progress. I don't think this is in review. So we need to do some investigation, and if there needs to be some action or something, we just address.
Agree. And actually, let's put this timing back in here as well, back to in progress, just because that's should probably be the same thing, but whatever. All right. And then I think, I think we did merge this in. Nope. Okay.
The feedback needs some work. So I did something for PX4, which needs to be backported here.
Okay. So all right. So the feedback, which is currently sitting in what? Planned, but not as even in to do. I do think this should at least be a to do item.
Well, it used to work, but AM32 doesn't have proper timings. The timing is actually just terrible. And it turns out that the guys at Betaflight and ArduPilot just fixed it on their side. And I also did it now on PX4. So we also have to fix it on the CogniPilot side.
Okay.
Before the BOHeli ESCs, they do the time compensation. They compensate for it.
All right, and then let's just scroll through this really quickly here. So I think this technically got merged right here, this one. So whatever, I'll put that into do. You know what? Let's put it in in progress. Let's go here to.
Is this the boot up bug fix?
No, this is the internal Flash programming, so we can actually use a bootloader with the K344.
Understood.
Zenoh message IDL bound strings. Let's put this in the to do because we know that we need to figure out Zenoh here.
Well, we found the trick, right? So the trick is that you patch the IDL before throwing it into that generator. So ROS doesn't, like, there's always a byte that tells what the size is. But if you just bind it, then the allocation just never allocates more. And then we serialize like up to 20 or 30 bytes. And if we deserialize, then we just say, well, you just send me 40 bytes. I don't want this anymore. You just throw an error while deserializing. So actually patching the IDL. And then the idea was to check in the IDL. So that's where that kind of stopped.
Would you mind just going over sort of the methodology that you use just on this for just a minute or two and maybe screen share if that's all right, Peter, just so that way we have it for posterity's sake for anybody else who's like, what's going on? Or like even for Lewis to look back at or me to look at, just to sort of follow better. Because I feel like every time I go back to look at it, it's been just the right amount of time for my poor old man brain to have forgotten it, and I hate having to keep asking you. So I don't know if you feel comfortable with sharing that.
The idea, well, I could do it, but the idea was to, like, that branch kind of got thrown away because shit changed too much. But pretty much we do that trick, but then on the IMU that works at 800 hertz, and then we just make one single ROS2 topic that publish like the correct IDL. It's still a bit of a hacky implementation. But then from there we can expand further.
Okay. Because yeah, right now it's all basically on this Zenoh branch, right? And if we look at this, this is where everything's packed into. Which, okay, you definitely did some magic in here that I don't know if I fully completely understand the magicness of. Where was it? Too large. Was it underneath this? Yeah, size of key expression. Some of this, some of the magic in here. I'm not sure how much. I don't know if there's a way to auto-generate some of this, but it sure looks. So this is what the liveliness key expression, or something.
Actually, I think they finally documented it because, like. So maybe you could just go to RMW Zenoh design document if there is. That's actually explaining all of this if you really want to know. Where is it? Oh yeah, here. Topic name is server to key expression. So effectively we get chat here, right? Where's the chat? There it is. Yes. So if you go to the specific key expression chapter.
Okay, I'm going to go like this. I'm just going to copy your link over here because I'm technically on 2 different accounts at the same time. All right.
So effectively, we know that PubSub has this concept of topics, right? And ROS also has this concept of topics. But under the hood, Zenoh does a way longer topic to do some basic type checking and ROS domain ID. So effectively, you have ROS domain ID, which is 0 to 236 or something. It's like a weird number. It's not 255. But then you've got chatter. So technically, the topic in this example is the /chatter. Then you have the ROS string name, and then the RHS string. That thing is the hash that is used for type safety because although it's not a very nice hash because someone want to have like cryptographically correct hashes. So we're like, let's do SHA-256 because that's cool for macros. I shared my concern about that, but I don't know. I got down. You told me to put that on Reddit. I got downvoted.
What?
So, yeah.
Probably the same guy who downvoted my stuff
Well, the cool part is actually they made it such that you can make an RAH like 02 one day, so maybe we can But I don't want to go through this whole committee stuff, right? It's like, hey guys, it's very long ass strings, but effectively you have to do two things. So you have the topic, and then the other thing is the graph cache. So effectively like ROS2 node list and RQT graph, and that's where the liveness topics come in. So the liveness topic is to pretty much tell what it is. So you have to register those topics, and then you the livenesses, and then you register the topics corresponding to it. And that's how ROS figures out how to subscribe or publish to something. Effectively, Ben, if you screw up, this is where actually it's still flat ROS is interesting. Like we have this RHS 01 something something something, right?
Mm-hmm.
Maybe we can just do like RHS 02 with a smaller hash that's flat buffers. Your problem, right?
Yeah.
And then ROS just calls the different serializer. Actually, you could kind of hack that quite easily in there, and then we can just show the CPU load. So. But effectively, that printfs are generating those topic names. It looks dirty. The guys that are doing the other ROS microcontroller implementation are doing it quite similar. It's just the most simplistic way to build strings like that.
Yeah.
And that's where that thing comes in, and that's where the function, right? So you just have a buffer with a topic, and then you have to put your hash in there. You have to put the type in there. You have to put the key expression there, and then we register that as a topic.
Okay. Now, with Zenoh, if we're sending a multi-message, I guess that's my next question. So, like in regular ROS IDL, you can have a message of messages, right? How much does that hose us with this approach with Zenoh?
Well, that's all in the IDL stuff. So,
okay.
Zenoh doesn't care about it. The whole point actually of Zenoh is to not care about serialization. That's someone else's problem. That's their approach, which is interesting because, well, they just focus on like decent graphs and decent performance. And actually, it would be nice that even ROS just embraced to not do serialization for certain data types, because Zenoh even has abstractions of data types, like HTML has for like application JSON and so on. So you could also do like video RTP and just send raw RTP data over Zenoh instead of doing serialization, deserialization, which actually would solve the whole video problem ROS still has, right? Because we're like, let's containerize video in a different format because it's not a solved problem.
Yeah. Okay. Yeah, no, awesome. All right. Did anybody have anything else they wanted to go over? Got technically 5 minutes left, but I'm also fine ending 5 minutes early. By the way, Peter, do you know when you'll have time to revisit any of the Zenoh related stuff here on CogniPilot?
Next year. Maybe,
next year?
probably, most probably, yeah.
Okay, so never, basically. Okay.
Yes.
Nice way of saying never. All right. Cool. All right. Well, I think if that's it, James, did you have anything else, or Lewis, anything else you wanted to share or go over?
No, Lewis, I think if you want me to invite you to that Thursday morning to, watch it fly, I think that could be good. But we could also have you join later after Ben and I, work out all the stupid ESC stuff. So maybe like, I'm thinking we go in at like 9 o'clock, and then maybe by 11 we'd probably have it flying. Does that seem reasonable?
Yeah, just invite me to the meeting and I can join.
Yeah, I'll do that.
Yeah,
Thanks.
and then I think for me Thursday, yeah, that should work fine. I see your invite, James. So
Yeah.
Yep, I accepted it, and then I'll just forward this on. Or do you want to just forward that on to Lewis, and we can let him know when to join, so he can block it out as a.
What's your email, Lewis? That you want me to send the invite to?
LewisF@croxel.com.
Croxel, CROXEL.
LewisF@croxel, CROXEL.com.
That's correct.
Okay. All right, cool. Yep. All attendees. There you go. I also got the 4 drones. They're currently sitting in my entryway, so students having to crawl around them. But we have 4 new drones. So yeah.
Hey, there you go. And you will be getting the ESCs already pre-soldered and made with wiring and everything else to just plug and play.
That's amazing. All right.
So
Cool.
I would suggest, please don't let the drones just collect dust in the box. I don't know, maybe see if one of your grad students is willing, or get yourself a beer on a Saturday night, sit there, put on some Netflix and build them. Something.
Yeah, there you go.
All right. Sounds good. Well, I'll go ahead and wrap up the call. Thank you guys for joining. And yeah, let's keep up on Discord and also on GitHub.
Sounds great. All right. Bye.
All right, bye.
Thanks, everyone. Bye.